Okay, so when it comes to sewage pumping, so usually if when we want to have our sewage treatment plant, there's actually always a planning lah. So to not have additional sewage pumping. So we don't want to have underground pumping station lah. So as I mentioned, if you don't have a pump in place, and then or if the pump fail, then what's gonna happen? You cannot flush the toilet lah. So the sewage will backflow back into your WC. So when it comes to sewage pumping, we do not want to have an intermediate separate building or another service center. We want it to have all of it at the sewage treatment plant. So there should be some planning in place lah to ensure that all our pipe is at a good gradient, even though it's very deep, to our sewage treatment plant. So, but in the case where there's no choice, so there's something we have something like this lah. So when we have no choice, where the when the service point for our sewage is higher than our building, then we will have to put in an underground pumping station. So we want our pump to be having all these requirement, which is reliable, unchokable, robust, wear resistant, and accessible for maintenance. And then we also want to have two units of pump, one for working, another for standby lah. But usually in the case of planning, we do not want to have this lah unless it's unavoidable, where your sewerage point is higher as opposed to your building. But usually we want to, when we build a sewage treatment plant, we want it to have it as low as possible lah, so that all the pipe can flow into them. Or you can connect it to a pipe, a separate pipe that leads to the sewage treatment plant. Okay, so when it comes to disposal of sewerage, so there can be two methods lah. So essentially, we want to treat it first before disposing of it. But then depending on how we service this sewerage, we can have it in two methods lah. Either we call it a broad irrigation or we call it a dilution into river or sea. Okay, let me check everything is okay. Okay, so this one, when it talks about broad irrigation, the treatment will include screening, and plain settling. But this is already not practice lah, because we're actually just disposing of the sewage. So when it comes to irrigation, we want to liquefy it before we discharge it into an irrigation field. Or when it comes to discharge it to our sewage or stream, so we want to make sure it's clean lah. First, we need to purify it. And then after that, if we have conservancy, so we want to discharge it into our cesspool or septic tank, and then remove it away. And then finally is dilution lah. So we don't do this or this. So this one also we don't have it lah in Malaysia. So dilution, this is not allowed anymore lah, because cause a lot of problem. So just a general idea of how sewerage can be disposed of. Okay, so we come to the final portion of this chapter. So in this chapter, this is the only calculation we have, which is the charges formula. So, but before that, we need to know some basic formula lah, which is the flow rate of water, where we have Q equals to V over T. Q is the discharge rate or the flow rate given in meter cube per second, and then how much volume passing through a second. So V over T lah, Q is equals to V over T. And then this is another important formula. So which is Q equals to VA. So what is our discharge rate? It's also equals to our velocity by the pipe area. Okay, we have this Chassis formula, which is the flow lah for calculating our sewage flow in a pipe or an open channel. So C is actually a constant. This will actually be given to you or in the question itself, or it will be stated lah that you want to use the value of C to be 55. So this one is C, and then you have your velocity, which is this V, and then you have your hydraulic mean depth, which is this M, and then you have your inclination, which is I. So okay, so because this is C is constant, then it will be given to you or in the question itself, then you don't have to worry about it lah. So in Chassis formula, we want to find out what is the velocity of flow using from this item. So to get the M, if you look at it here, so M is basically means this lah. So M is a hydraulic mean depth. So it's actually meant by cross section of area of flow divided by length of wetted perimeter or something like this. So depending on your question, but okay. So depending on your question, if we have a round pipe, based on this, you can always assume that D is over 4 for your M. So this is fixed for a round pipe given the situation of full bore and half full. So for a situation where your pipe is fully filled with water, and for your pipe only being half filled with water, your M, your hydraulic mean depth, is equals to D over 4. Okay, so for your I, inclination of 4, is the depth of how much changes in 4, meaning from point A to point B, is it 1 meter over 100 meter of difference, 100 meter of length, there will be a drop of 1 meter. So you have 1 over 100, which is explained here with the difference between H and your L. So it's your hydraulic gradient. So for I is pretty straightforward. And then, okay. So, and then besides that, you have this. So to find out the constant, you can either it's given to you or you use formula. So how we get a constant 55 value is through this formula. So here, Chassis constant, you have square root of 2 multiplied by the gravity, which is 9.81. And then after that, we have our friction coefficient of friction, which is a constant value depending on the material of your pipe. So you can either be given this value straight away, or you can be given this F. So based on this F, you can work out what is your chassis constant value. Okay, so I think this is pretty straightforward for your C and for your I. So in chassis formula, you want to find out what is your V. So a bit on the hydraulic mean depth. So here, pay attention here. If your pipe is a round pipe, and then if the water is full, and if the water is only half filled, you can assume that your M is equals to D over 4. So this is the case for only, this is important for round pipe. But if your pipe is a square, then it will be different. So just for example's sake, if it's a square, then this does not apply anymore. So let's say, for example, I'll work it out for you guys to show you. So this pipe is, let's say, only half filled. So we can find out what is the hydraulic mean depth of this square pipe by using this formula. So we know what is the cross-section area of the flow, and then we know what is the length of the wetted perimeter. So let's say, for example, we give this A, and we assume this bottom as a B. So to work out the M, we will have our cross-section, which is A, multiplied by B, and then divided by what is the length of the wetted perimeter. So we have A plus B. So this is the case if you're given a square pipe. But if you were to work it out for a circle, then we can have area of flow which is pi over 4 d square. Because it's a full circle, this is the cross-section area of, this is a formula for the cross-section area of the full circle. So this is a formula using diameter. And then if it's R, then you know it's a pi R square. So here, when you are calculating area of flow, it's better for you to not always refer to this. It's better for you to always use this formula, hydraulic mean depth, where cross-section area of flow divided by wetted perimeter is your M. So to work out this, if it's a round, then you have a full area. So here, you can either use this formula, or you can use R, which is pi R square, which is equals to this, and this is the same, pi R square, divided by the wetted perimeter, which is pi D, or pi 2R. So it's the same thing. So you end up with the same value, which is D over 4. So if you work out this and this, divided them together, they are essentially the same. So if you cut the 2 away, this will become 4. So it becomes identical. So that's why in the case of a round pipe, this is where the D over 4 equals to M comes about. So just an idea of the difference between round pipe and a square pipe. Although in actual case, you will not have a square pipe Okay, so example, we got 2 examples here. So example 1, we have is to find out what is the discharge capacity lah, using Chassis formula. So we have a pipe of 200 mm diameter, flowing full, so it's a full bore, and then it's given that this is laid in a 1 to 200, so meaning here this is 1 meter fall after 200 meter, or 2 to 1, 1 to 200 ratio. And then you're given that C is 55, so you're not given the F. So if you're given the F, then you will need to work out using this formula. Okay, so with this, you know that your C is 55 from here, and then this is your hydraulic mean depth, so which is D over 4, based on what we worked out before. So your D is this 200 mm, convert it to in meter. So this you need to make sure you need to convert it to meter. 200 mm is equals to 0.2 meter divided by 4 over 200. This is because the I is 1 over 200 based on this. So 1 over 200. So with this, you'll be able to work out what is your V. And then with your V, we know that Q is equals to VA. So to find out what is the discharge capacity, meaning how much water, so this is in meter cube per second. So we have our V, we put it into here, and then we multiply it with our area. So what is the area of the circle? So in this case, our diameter, although it's not mentioned directly, this is a circle sewer pipe, but as here mentioned, this is a pipe. So usually it's round, and then you're given a diameter. So here. So the area of a circle, which is this, so I use pi r square. I use radius to find the circle. Then we'll be able to get for Q, which is 0.027 meter cube per second. So we know that 1 meter cube is equals to 1,000 liter. So we will end up with something like this, which is 27 liter per second. So depending on what is mentioned in the question, so if we leave it here, it will be good enough unless the question is asking you to give in this, then you have to convert. Okay, so another example here, we are still using the Chassis formula, but instead of giving you the diameter of the pipe, you're given the discharge, which is 20 liter per second. So here, you're given information that this is a full bore. So a full bore pipe, we can use D over 4. And then the 4 is 1 is to 200, and the C is 55. So with that, you'll be able to use this formula here with Q equals to VA. We can substitute our value into our formula. So once we substitute our Q equals to VA here, so we end up with Q equals to A multiplied by our Chassis formula here. So we can further solve this equation with M equals to D over 4. Then we will end up with something like this, and we also expand our A. So we expand our A area, we'll be able to get pi over 4 multiplied by D square. This is our area. Our C is a constant, and then we have our M and I. So we expand our M to D over 4, in the case of a round pipe. So we'll be able to end up with something like this. Then we put in all the formula, we solve the equation. So we end up with something like this. So we can solve it normally. You will get this d5. Once we move it around, multiply it, you get d to the power of 5 equals to a very, very small value. And then this is the important part. You need to be able to square root it by 5. So move this to the right, and then you can square root it by 5, and you'll be able to get a value, which is 0.177 here. So the question mentioned suggests. So when it comes to suggesting a size, you want to make sure it's bigger than what you found here. So an example of how your question can be like. So in your tutorial, you have a question like this also So do practice on this to make sure you can do this step So if you are not able to, please ask or please tell me so I'll show it to you. So I'll assume you know how to do it Okay, so this is it for this chapter. So on the next chapter, topic 6, there won't be any calculation So this is a final calculation for you guys.